Hello, Year 13. I hope you're okay. Sorry I'm not in for your lesson today. Obviously, it's quite up in the air about what's going to happen over the next few weeks, especially with your exams. But I think it's really important at the moment that you just carry on, all right? All the skills that you're building, might come in useful in your university courses and things like that. So we need you to be as prepared as possible, okay? So those of you that were in, which was all of you except Jaja actually on Tuesday, we were looking at further kinematics. Okay, so kinematics in two dimensions, constant acceleration with the Suvat equations, and then looking at variable acceleration where you have to integrate and differentiate. So, plan for today's lesson is, if you listen to me, I'm going to go through example 10, which is the last one in your booklet. And then if you go onto Google Classroom, I'm going to ask you to do some questions. And then once you've done them, if you send me your answers by like message, by like taking a photo of your solutions, I can look through them and give you feedback on them. Okay, that's my plan. All right. Okay, so example 10 then. Just to recap, we were looking at integrating and differentiating for acceleration, velocity and displacement. So we know that to get from displacement to velocity, we differentiate, and to get from velocity to acceleration, we differentiate, okay? And the opposite, acceleration, velocity, displacement, we integrate, all right? So this starts off saying the velocity of a particle at time t seconds is 3t squared minus 8I plus 5j meters per second. It also tells us that when t equals 0, the position vector of p with respect to a fixed origin is 2I minus 4j, okay? First thing it says then is find the position vector of p after t seconds. So you've got a velocity, and this time because you want a position vector, okay, you want a displacement. And remember, the textbook likes to call it r, so I'm just going to go with that for the time being. So if we want to find r, okay, we integrate the velocity with respect to time. So we're going to be integrating both parts, 3t squared minus 8I, okay, and 5, I'm just going to pop it in a bracket so it looks the same, 5j with respect to t, okay? So if we integrate 3t squared minus 8, t squared becomes t cubed, and when we divide by the power, 3 divided by 3 cancels, and 8 will become 8t. So we get 8ti plus, it's just 5, so it's 5tj. Okay, now remember for that, what we've now got is we've also got, because we've integrated, a constant of integration, and that constant of integration, okay, will have an I and a j component. Okay, so you might want to write it as t cubed minus 8ti plus 5tj plus pi plus qj. Okay. And if we look now at the information we've been given in the question, we know when t equals 0, okay, the position of p with respect to the origin is 2i minus 4j. So we know 2i minus 4j is equal to, this will cancel out to 0, this will cancel out to 0, so it's equal to pi plus qj, okay? So we can then say from that p is 2, and q is minus 4, okay? Putting those two bits of information back with this and kind of collecting the like terms, if we look in the I direction now, can you see we've got t cubed minus 8t plus p, so plus 2i, okay? And then in the j direction, you've got 5t plus q, which in this case is minus 4, j. So it's like I'm factorising out an I and j. We treat it like algebra, but we know that I tells us any movement east and j tells us any movement north. Alright, so that's the first question because it just wants it in t seconds. If it asks for a particular amount of seconds, we just put t in now. Alright, if it asked for a distance, we'd put the value of t in, and then we'd have to use Pythagoras to work out what that distance would be. Alright. So for part B, just let me move my paper a little bit. Okay, sorry. So it says a second particle moves with a constant velocity of 8I plus 4j. So constant velocity. So think about right back to the beginning of this booklet. If we know a constant velocity, okay, we can find the distance it's travelled, or the displacement I should say, it's travelled by multiplying by t, okay? That would tell us the displacement it's travelled, and then wherever it started from, we'd need to add on, okay? So I'm just going to write that a little bit more mathematically. So for particle Q, all right, if we want to know its position, t seconds after wherever it is, okay, it'll be its initial position, which we'll call R0, plus the velocity times time. I think it's the first page of this booklet if you flick back to it. So in this case here, R is going to be equal to, if you look at the question, it says when t equals 0, the position vector with respect to the fixed origin is 2I. So we've got 2I plus t times 8I plus 4j. Okay, so if we expand that and get it equal, if we expand that and get all the like terms together, okay, can you see in the I direction you've got 8t plus 2, and in the j direction you've simply got 40j. Okay, now the other way to get that exact same value would be to integrate that. So if you were to integrate 8, you'd get 8t. If you were to integrate 4, you'd get 40. Okay, and again, you'd have your constant of integration, you'd substitute 2i, and you'd end up with exactly the same answer for that bit there. Okay, so this now says, prove that P and Q collide. Okay, sorry. So if P and Q collide, can you see that the I components of these two answers here and here would have to be equal, and the j components of these two answers here and here would have to be equal for a value of t that was the same for each. Now if we look at these two equations, here it looks like it's much simpler to look at the j components rather than the i's. Alright, so that's what I'm going to do, okay? You can check it for the I components if you want to after, just to check it works. But if we look at the j components, if they collide, they're at the same place at the same time, okay? So what we can do is we can say 5t minus 4 from the j component of P is equal to 40 from the j component of Q, all right? If I solve that equation now, so take the 40 over, I've got t equals 4 seconds. So that tells me that P and Q, if they collide, have to collide at 4 seconds. If I was to possibly, and I've not done it, so I don't know, but if I was to solve this equation, so this one equal to this one, it might end up I get more than one solution, and I might have a bit more work to check. But in order to show that they collide, what we need to do now is we need to substitute t in to show at t equals 4, where is P and where is Q. So at t equals 4, P, okay, will be at 4 cubed minus 8 times 4 plus 2i plus 5 times 4 minus 4j, okay? So 64 take 32 is 32 plus 2 gives me 34i, and then 20 take 4 plus 16j. So at t equals 4, that's where P is, 34i plus 16j, okay? For Q then, we now do the same thing here. So for Q, R will be at 8 times 4 plus 2i plus 4 times 4j, okay? And if we look, 32 plus 2, we get 34i plus 16j, okay? So we can now see, okay, both P and Q are at the same position at t equals 4, therefore they must collide. Okay? Alright? Right, so make a note of that on yours, alright? And I'm going to set you some questions But please just get your phones out once you've done them, take a picture of them, send me the answers so that I can mark them and get some feedback to you, just so that you know that you understand. All right. Hope you're all okay. Take care over the next few weeks, and I will be doing some more videos and maybe some Google Hangouts as well, just so that we can all keep in touch. Thanks a lot. Bye.